Bienvenue à la COP 29, en Azerbaïdjan, où les discussions sur le climat prennent un tournant crucial. Avant de plonger dans les débats passionnants qui nous attendent, rappelons-nous des événements récents qui soulignent l'urgence de la mission de la COP 29. Le président américain, face à une vague de froid inédite aux États-Unis, a remis en question le réchauffement climatique. Dans un tweet provocateur, il a ironisé sur la nécessité d'un peu de « bon vieux réchauffement climatique ». Cette déclaration, loin d'être une première, reflète une méconnaissance alarmante des enjeux climatiques. La communauté scientifique a réagi promptement, soulignant la différence cruciale entre météo à court terme et climat à long terme. L'année 2010, l'une des plus chaudes enregistrées, témoigne de la gravité de la situation. L'abandon de l'accord de Paris par les États-Unis a également été évoqué comme une décision controversée au regard des efforts mondiaux pour lutter contre le réchauffement climatique. Pour le programme, nous commencerons par la salle 202 dédiée à la modélisation du climat. Ici, les experts discuteront des outils et techniques avancés qui nous aident à comprendre et à prévoir les changements climatiques. Un sujet technique, mais essentiel pour guider nos politiques environnementales. Nous nous reverrons après la conférence.
Ladies and gentlemen, distinguished delegates of COP29, the importance of mathematical simulation in our understanding of climate is fundamental. Our planet, constantly receiving solar energy, is the scene of a complex redistribution of this energy. Low latitudes, bathed in more sunlight than the poles, generate climate dynamics that we must understand and anticipate. Mathematical simulations are at the heart of this understanding. They enable us to divide the atmosphere and oceans into small meshes, analyzing the evolution of each segment by taking into account a balance of energy and matter. This incredibly detailed process helps us to understand the interactions between the different parts of our climate system. The optimistic simulation, as conceived by the most advanced climate models, presents a future where humanity has succeeded in taking significant steps to reduce greenhouse gas emissions and limit global warming. In this scenario, the actions taken on a global scale are in line with the most ambitious objectives of the Paris Agreement, aiming to keep the increase in global average temperature well below 2 degrees C compared with pre-industrial levels, and to continue efforts to limit the increase to 1.5 degrees Celsius. The most crucial aspect of this scenario is a rapid and significant reduction in emissions of CO2 and other greenhouse gases. This is achieved through a global energy transition to renewable sources, electrification of transport, improved energy efficiency, and an agricultural and industrial revolution that promotes sustainable development. In addition, carbon sequestration is being intensified through massive reforestation and the restoration of degraded ecosystems. Carbon capture and storage technologies are deployed efficiently, helping to extract CO2 from the atmosphere and achieve carbon neutrality. Thanks to these efforts, the rise in global temperature has been kept to a manageable level. Models show a flattening temperature curve towards the end of the century, indicating that the temperature rise is stabilizing as a result of the measures taken. Sea level rise is also moderate in this scenario. Although some changes are inevitable due to the heat already absorbed by the oceans, efforts to reduce emissions and protect coastal ecosystems are helping to reduce the speed and scale of this rise. Ice caps and polar ecosystems are largely preserved, minimizing the positive feedback loops that could otherwise accelerate warming. Reduced Arctic ice loss helps maintain the Earth's albedo, reflecting more of the sun's energy back into space. Overall, the optimistic scenario depicts a future where life can continue to thrive on a planet with stabilized climatic conditions. This does not imply that climate change is entirely avoided, but that its impacts are managed and societies adapt to a new ecological equilibrium. As climatologists, we know that this optimistic future is not guaranteed. It requires determination, international collaboration, and substantial investment in technology and innovation. However, this scenario is not a mirage. It is a concrete possibility if we choose to act with the urgency and scale required to tackle the climate crisis. In this optimistic vision, every nation, every company, and every individual has a role to play. It's a call to action, not just for decision makers and scientists, but for all the world's citizens. The pessimistic climate change simulation represents a future in which the actions needed to mitigate the effects of global warming have not been adequately taken. In this scenario, greenhouse gas emissions continue to rise, and global efforts to reduce them are insufficient or ineffective. In this scenario, dependence on fossil fuels and lack of investment in renewable energies lead to a continued increase in emissions of CO2 and other greenhouse gases. Attempts to reduce emissions are fragmented, and there is no effective coordination at international level. As a result, the planet's average temperature is rising significantly. Climate models predict a rise of up to 4 degrees Celsius or more by the end of the century, compared with pre-industrial levels. This rise in temperature is having devastating effects on ecosystems, causing extreme heat waves, disrupting precipitation cycles, and increasing the frequency and intensity of extreme weather events. Sea level rise accelerates in this pessimistic scenario, exceeding 1 meter and threatening densely populated coastal areas. This rise is the result of accelerated melting of the ice caps and thermal expansion of the oceans. Coastal flooding is becoming more frequent and more devastating, leading to massive population displacement and significant economic losses. The melting of polar ice and glaciers is accelerating, leading to a reduction in albedo and an increase in the Earth's absorption of heat. Polar ecosystems are being disrupted, affecting both marine and terrestrial biodiversity. Phenomena such as coral bleaching and loss of biodiversity become widespread. The social and economic impacts of this scenario are considerable. They include humanitarian crises due to resource scarcity, forced migration, disruption of food supply chains, and an increase in resource-related conflicts. The economic costs of adapting to and responding to natural disasters increase exponentially. This pessimistic scenario is not a foregone conclusion, but a warning. It underlines the urgency of acting decisively to limit greenhouse gas emissions and implement adaptation strategies. The choices we make today will determine whether this pessimistic scenario remains a projection or becomes our reality. As participants in COP29 and as citizens of the planet, we have a collective responsibility to ensure that this scenario does not materialize. Our future depends on the actions we take now. The inaction simulation, in the context of climate change, depicts a future in which no significant additional measures are taken to combat global warming. In this scenario, greenhouse gas emissions continue on current trends, with no significant worsening or improvement. While this may seem less extreme than the pessimistic scenario, it nevertheless entails serious and lasting consequences for the global climate and environment. In this scenario, the world continues on its current trajectory in terms of greenhouse gas emissions. This means that while emissions are not increasing significantly, they are not decreasing either. Levels of CO2 and other greenhouse gases remain high, exacerbating the greenhouse effect and contributing to ongoing global warming. Without additional measures to reduce emissions, the global average temperature will continue to rise, albeit perhaps at a slightly slower rate than in the pessimistic scenario. However, even this gradual increase has significant implications, including more frequent and intense heat waves, changes in precipitation patterns, and intensification of extreme weather events. Sea level rise continues at a worrying rate, resulting from the ongoing melting of ice and the thermal expansion of the oceans. Although the rise may be slightly less rapid than in the pessimistic scenario, it continues to pose significant risks for low-lying coastal areas, river deltas, and low-lying islands. Ecosystems continue to come under pressure from global warming and other environmental factors linked to human activity. Natural habitats, such as tropical forests, mangroves, and coral reefs, are being disturbed and degraded, leading to a loss of biodiversity and the disappearance of crucial species. The social and economic impacts of continuing current trends are not negligible. Agriculture, fishing, and other key economic sectors are disrupted, leading to food security problems, loss of livelihoods, and increased inequality. Forced migration due to environmental change and resource conflicts may intensify. The no-action scenario is a clear warning that business as usual is insufficient to address the climate crisis. Even in the absence of increased emissions, the cumulative effects of greenhouse gases already in the atmosphere will continue to have a significant impact on the global climate and ecosystems. It is therefore crucial that measures are taken not only to stabilize, but also to actively reduce greenhouse gas emissions and mitigate the impacts of climate change.
Climate modeling is an essential tool for understanding and predicting future climate. It uses fundamental physical laws to simulate the complex interactions between the atmosphere, oceans, cryosphere, and biosphere. These models enable us to quantify the responses of the climate system to various forcings, such as greenhouse gas emissions or changes in land use. To validate climate models, it is important to test them against periods for which we have past climate data, such as glacial and interglacial periods. These paleoclimate simulations use geological data and evidence, such as ice cores, to reconstruct past climates and test whether the models can reproduce these known conditions. Understanding the components of the climate system is crucial. This includes not only physical elements such as the atmosphere and ocean, but also biogeochemical processes such as the carbon cycle and interactions with the cryosphere. Each component plays a role in climate regulation and can contribute to positive or negative feedbacks that amplify or mitigate climate change. To elaborate on these points during a conference, we could discuss how improvements in climate model simulations have reduced the need for corrections and increased confidence in climate predictions. The challenges posed by the uncertainties inherent in climate modeling could also be addressed, highlighting the need for further research to refine these models. In addition, discussions could focus on how paleoclimate simulations can not only inform us about past climate, but also help us understand potential climate responses to current human perturbations. Finally, an in-depth exploration of the different components of the climate system could reveal how they interact to produce the climate we experience, and how changes in one component can drive changes in others, often in non-linear and unpredictable ways. Nous revoilà, prêts à explorer la salle 303, Responsabilité humaine dans le réchauffement climatique. Cette session s'attardera sur l'impact des activités humaines sur le climat, une réflexion profonde sur nos responsabilités et les actions nécessaires pour atténuer notre empreinte.
Ladies and gentlemen, distinguished delegates to COP29, honorable representatives of the international community, we meet today to address an exceptionally serious issue, global warming, whose urgency transcends borders and generations. Our discussion takes place against a backdrop where, despite the undeniable accumulation of scientific evidence, a veil of skepticism continues to hang over the reality of climate change. Allow me to dispel this fog of uncertainty by presenting you with a rigorous, quantified analysis of the factual data that challenges us. I'll start by examining the anthropogenic influence, undeniably attested by the correlation between greenhouse gas emissions and rising global temperatures. Documents we have examined reveal that human activities, particularly since the advent of the Industrial Revolution, have greatly contributed to the increase in concentrations of carbon dioxide, CO2, methane, CH4, and other greenhouse gases in our atmosphere. It should be noted that these gases, through their ability to trap solar heat, play a major role in the greenhouse effect that governs our climate. A detailed analysis of CO2 emissions by sector in France in 2013 reveals that 69.4% came from the use of fossil fuels to produce energy. The cement sector alone, through the calcination process, is responsible for 2.9% of French CO2 emissions. Although these figures are specific to one nation, they reflect a global trend in which industrialization and the burning of fossil fuels are the main drivers of climate change. Landfill sites, veritable ecological scars, emit not only CO2, but also methane, a greenhouse gas 25 times more potent than CO2 over a 100-year horizon. Each French person contributes an average of 600 kilograms of waste per year, with around 230 active landfills in France, releasing significant quantities of greenhouse gases. Let's turn to agriculture, where livestock farming represents a significant source of CH4, notably via enteric fermentation in ruminants. In 2018, France had around 19 million cattle, with agricultural production generating 40% of the country's CH4 emissions. These data highlight the considerable impact of our food choices and farming practices on the climate. Deforestation, that silent hecatomb, is also a major factor. Between 1990 and 2015, 240 million hectares of forest were wiped out, accentuating the imbalance in the carbon cycle, where CO2 capturing photosynthesis is undermined by the burning and conversion of forest land. I'll go on to detail the images depicting industrial processes and their contributions to GHG emissions, where we see that power plants, transportation and various industrial processes are mainstays of the anthropogenic carbon footprint. Finally, allow me to highlight the IPCC simulations, which highlight the growing gap between temperature trends due to natural factors alone and those where the human footprint is taken into account. Climate models are categorical. Without human influence, the temperature variations observed since 1850 cannot be explained. So, in the face of all this data, the climato-skeptic claim that there is no evidence that we have emerged from natural climate variability is not only unfounded, but dangerously misleading. Natural variations in the Earth's temperature, while real over the eons, cannot justify the scale and speed of the current warming. Ladies and gentlemen, the evidence is overwhelming and time is running out. It is incumbent on us, as guardians of our planet and our future, to take drastic and immediate action to reverse the trend of global warming. Inaction and denial are no longer viable options, if they ever were. If we look at the graphs depicting the global temperature curve, we see that the increase of around 1 degree C since 1850 has no precedent in natural variations on geological timescales. It is crucial to understand that this change has taken place in the space of 2 centuries, compared to similar variations that would have taken millennia or even millions of years in the past. This acceleration is unequivocally an anomaly in the graph of our planet's climatic history. This anomaly is all the more striking when we consider the cooling effect our planet has experienced over the last 130,000 years, during which time the global average temperature has fallen by almost 4 degrees C. The speed of recent warming cannot be explained by natural factors such as Milankovitch cycles or volcanic eruptions, but corresponds precisely with the industrial era and the exponential increase in fossil fuel combustion. What's more, the climato-skeptic assertion that there is no evidence to suggest that we are moving away from natural climate variability is contradicted by the striking similarity between the predictions of climate models, including anthropogenic factors, and actual observed temperature data. The discrepancy between simulations based solely on natural factors and those incorporating human activity leaves no room for ambiguity. Man's imprint on the climate is indelible. It is also imperative to underline the extent of human impact on ecosystems and biodiversity. Massive deforestation, ocean pollution, acidification of marine waters, and loss of biodiversity are not simply corollaries of industrial development, but symptoms of a profoundly unbalanced system. Man has altered more than half of the planet's habitable land, modifying the cycles of water, carbon, and other vital elements. However, it would be simplistic to confine ourselves to an assessment of failure. We are also witnessing an era of unprecedented innovation and global awareness. Green technologies, renewable energies, and sustainable practices are gaining ground every day. Initiatives such as the Paris Agreements, despite the challenges they face, embody the will of the international community to make a fundamental shift towards a more sustainable future. The role of science in this transition cannot be underestimated. Researchers around the world are working tirelessly to refine our climate models, develop innovative carbon capture solutions, and understand the complex mechanisms governing our climate. Their efforts are the lighthouse guiding us through the storm of climate change. Given the magnitude of the task, it is imperative to adopt a multidimensional approach. We must take legislative action to impose strict environmental standards, invest in the research and development of clean technologies, and educate our populations about the challenges of sustainable development. Ladies and gentlemen, as we contemplate the scale of the challenges ahead, we may feel overwhelmed by the weight of our responsibility. However, it is essential that we perceive this responsibility not as a burden, but as an historic opportunity to bring about positive, lasting change for our planet and for future generations.
Et enfin, la salle 404 nous attend avec le sujet « Scénario d'évolution climatique et leurs conséquences ». Ici, nous nous pencherons sur les prévisions futures et les impacts potentiels sur nos villes et le monde en général. Une perspective essentielle pour préparer et adapter nos sociétés aux défis à venir. Restez avec nous pour ces discussions captivantes et éclairantes. La COP29 est plus qu'une conférence, c'est un appel à l'action pour l'avenir de notre planète.
Ladies and gentlemen, honored delegates of COP29, we are gathered here today to confront a reality often debated, sometimes denied, but irrevocably proven by science: global warming and its tangible repercussions on our planet, on our town of Rochefort, and more broadly on our civilization. First, let's take a look at the graph depicting the evolution of ocean pH according to the IPCC scenarios. Two trajectories are open to us: the RCP 2.6 scenario, which assumes vigorous action to limit greenhouse gas emissions, and the RCP 8.5 scenario, a trajectory where little effort is made. The differences between these two paths are substantial. Oceanic pH, currently around 8.1, could fall to 7.8 by 2100, according to the most pessimistic scenario. A 0.1 drop in pH means a 30% increase in water acidity due to the increased dissolution of atmospheric CO2 in the ocean. The effects are already visible, as shown in the image of the pteropod, a small mollusk. Under normal conditions of CO2 concentration, it develops properly. However, after just 2 weeks' exposure to high levels of CO2, its development is hampered, its ability to swim reduced, and its shell begins to dissolve. Imagine the long-term impact on the marine ecosystem if we don't change course. Ocean acidification, illustrated in the third visual, is a complex chemical process with alarming consequences. Increasing the concentration of CO2 in the air leads to more carbonic acid in the water. This chemical change upsets the balance of carbonate ions, essential for the formation of the shells and skeletons of many marine organisms. This applies to corals and sea urchins, but also to the planktonic organisms at the base of the marine food chain. As for global warming scenarios and their implications, the Aladdin Climate 12 km model enables us to visualize them with precision. For our region of Poitou-Charentes, a temperature rise of up to 4 degrees C is conceivable according to the RCP 8.5 scenario. This warming would mean fewer frost days and more hot days, exacerbating the risk of soil drought, which is already a major cause for concern. Finally, the IPCC report warns that sea levels could rise by up to 1.10 meters by 2100. The rate of rise is accelerating, threatening to submerge low-lying coastal areas where over 1 billion people live. If we do not drastically reduce our emissions, we are condemning these regions to catastrophic flooding. We must therefore approach this conference with the gravity and urgency that the situation demands. Our action or inaction will determine the future not only of Rochefort and the Poitou-Charentes region, but also of our planet. We stand at the crossroads of our climate history, an inflection point that demands not only understanding, but also action. Sea level rise, projected at up to 1.10 meters, is not just an abstract figure. It represents millions of lives, ecosystems, cities, and cultures at risk of being swallowed up by the waves. For towns like Rochefort, with its illustrious maritime history, this could mean a radical transformation of the coastal landscape, land erosion and salinization of groundwater, threatening our agriculture, infrastructure, and habitats. Rising sea levels mean more frequent extreme events. More violent and frequent storms, coupled with higher tides, could cause catastrophic flooding, even outside areas traditionally considered at risk. Our region's built and natural heritage, port activity, agricultural production areas, and unique biodiversity could suffer irreversible damage. Global warming and ocean acidification are not isolated issues. They are intimately linked to the health of our oceans, which, as the IPCC report points out, have absorbed around a quarter of CO2 emissions and 90% of the additional heat generated by these gases. Sea temperatures are rising, their chemistry is changing, affecting marine life, our fisheries, and by extension, our food security. While the Paris Agreement marked an international commitment to limit global warming to +2 degrees C or even +1.5 degrees C, current commitments point us towards a world at +3 degrees C. This half-degree difference may seem tiny, but it has the power to define the future of millions of species, including our own. The question we need to ask is not whether we can afford to act against global warming, but whether we can afford not to act. High-resolution climate modeling clearly shows us the consequences of inaction: an amplification of extreme weather phenomena, longer and more frequent periods of drought, and an unprecedented loss of biodiversity. We have an obligation to reduce our greenhouse gas emissions, develop adaptation strategies for our coastal communities, invest in renewable energies, and transform our agricultural and industrial systems to make them resilient in the face of climate change. As speakers at COP29, we bear the responsibility for this transition. We must be the architects of a future where climate balance is restored and preserved. It's a daunting challenge, but it's also an unprecedented opportunity to rethink our relationship with nature and build a sustainable world for future generations. I thank you for your attention and look forward to continuing this essential discussion.